Good day, everyone. We are the Group 10, and the application we are developing right now is Basic Java Programming Learning Management System, and also known as CODEX Java. So, for today, we'll be presenting the algorithm implementations in our project. Specifically, we'll walk you through how we implemented a rule-based classification algorithm, which is the algorithm that was given to us by our professor in software engineering and HCI, and it is implemented in our initial test feature, which determines each learner's proficiency level in Java programming.
Okay, so this is our rule-based classifier algorithm implementation in a step-by-step. Step 1 is test initialization and question loading. When the initial test begins, the system needs to create a balanced assessment by loading exactly 10 questions from each difficulty: beginner, intermediate, and advanced. For the code breakdown, the question list that clear empties any existing questions to start fresh. Then the get random subset, beginner list, and beginner count randomly selects 10 questions from the beginner pool. The same process repeats for intermediate and advanced questions. While the question list that add all combines all 30 selected questions into one master list, which creates a total of 30 questions with equal representation across all difficulty levels. For step 2, recording test start time. The moment the test activity is created, the system captures the exact timestamp when the learner begins the assessment, which serves as our baseline for calculating how long they spent on each individual question throughout the entire test. For the code breakdown, test start time equals system.current current time mil is captured the current time in milliseconds. This timestamp is stored as a long variable that will be used as a reference point. For the step 3, tracking question display times, as the learner navigates through each question, the system records the exact moment when each question first appears on the screen, creating a timeline of when the learner starts viewing each question so we can later calculate how much time they spent on it. For the code breakdown, question start times is a hash map that stores integers and long pairs. Then the if not question timestamp that contains key index checks if we've already recorded this question's timestamp. Start time, I mean. Then the question start time that put index system current time mil is saves the current timestamp for the question. And then for the step 4, capturing user answer selection, when the learner clicks on one of the 4 answers choices, the A, B, C, or D, the system immediately stores their selection in a memory, linking the question number to their chosen answer so it can be compared against the correct answer during the scoring. For the code breakdown, the user answer is a hash map with structured integer string storing question index and selected answer. The user answer that put saves the answers. And then the choice A that set on click is a click listener that press A when the choice is stopped. For the step 5, calculating time spent on each question, when the test is submitted, the system calculates how long the learner spent on each question by finding the difference between when that question was displayed and when the next question was shown, using the timestamp we recorded earlier to build a complete picture of their pacing throughout the test. And next, for the step 6, grouping scores by difficulty. As the system loops through all 30 questions, it checks each answer for correctness and simultaneously organizes the result into 3 separated categories based on difficulty. accumulating both the number of correct answers and the total time spent for beginner, intermediate, and advanced. And then for step 7, computing the average time per difficulty. Once we've accumulated the total time spent on all questions, the system divides each total by the number of questions in the category and converts from millisecond to seconds, giving us the average time the student spent per question at each difficulty. And then for the step 8, calculating raw scores percentages. Before applying any penalties, the system converts the number of correct answers in each difficulty into percentages, creating a baseline score that represents pure correctness without considering how fast or slow the student answered. And then for step 9, applying time-based penalty. This is the core rule-based logic. This is where the system examines the average time spent per question at, at each difficulty and applies percentage penalties if the timing seems suspicious, penalizing the learner who answered too quickly, suggesting random guessing, or too slowly, suggesting they looked up answers or got confused. And then for the step 10, computing general weighted average. After adjusting all three difficulty scores for timing behavior, the system combines them using a weighted formula that gives more importance to advanced questions, which is 40%, followed by the intermediate, which is 35%, and the least is beginner questions with 25%, producing a single final score that reflects the overall proficiency with emphasizing on the harder material. For the step 11, applying classification rules with the general weighted average calculated, the system now applies a simple threshold-based rule to categorize the learner into one of the three proficiency levels: the advanced if they scored 85% or higher, intermediate if they scored between 65% and 84%, or beginner if they scored below 65%. For step 12, identifying weak areas. Beyond just overall classification, the system analyzes performance on individual lessons by grouping questions by their source lesson, calculating the percentage correct for each lesson, and flagging any lesson where the student scored below 50% as a weak area that needs additional practice. And then for the step 13, saving result to Firebase. Once all calculations are complete, the system bundles the classification, general weighted average, breakdown scores, weak areas, and the timing data into a structured hash map object. Then save this comprehensive result to Firebase under the quiz result node, where it can be retrieved later for the progress tracking and analytics. For the step 14, updating user profile with classification. After saving the detailed test result, the system updates the user's profile in the users node of the Firebase by writing the new classification level, ensuring that when the learner logs in next time or navigates the application, their difficulty level is immediately known and can be used to customize their learning experience. And for the step 15 is displaying results to the student. Finally, the system presents a comprehensive result dialog showing the learner's score, classification with the color-coded visual styling, time spent, and the personalized list of weak areas they should focus on, giving them immediate actionable feedback on their Java proficiency and learning needs. And that ends the rule-based classifier algorithm implementation in code.
So, after a learner registers, they are immediately greeted by a pop up message to take the initial test. And as you can see, once the learner takes it, they can start taking the initial test. Here, you can see the test interface with the 30 questions. And you can notice the progress bar at the top showing the learner's progress through all 30 questions. There is also a timer ensuring the test is completed within the allotted time. Once the learner submits their answers, our classification algorithm processes the results on the back end. And here is the results page. The system displays the learner proficiency level, their general weighted average score, their time complete, and the weak areas identified by the algorithm. After taking the test, they can go to the home page to explore the app further.